Now, finally, we can have a look at our example. So this is what it looks like in the end. So we have a battery management system that's using the state of charge estimation, the AI algorithm for the state of charge estimation in this battery management system. And the algorithm was deployed on a processor. So here, what you can see is really the processor in the loop simulation. So the algorithm was deployed, then to the processor. The processor was connected to the system simulation, and we can see how it behaves. So this is for some data, for some real data. I was looking how the state of charge was. This is the yellow line, and the blue line was then the resulting, the AI model, how it behaves. And you could see it's behaving quite well. So here you can see the answer, like the state of charge from 0 to 1. And you can see how the battery management system has managed the state of charge. So it took care that there's no over or under charging. So in our example, we have the full system simulation, which has the battery management system and the battery itself connected. Then in this battery system, you can see the battery plant and the load. So this is the charging and discharging. And here you can see the logic of the battery management system. And one part, here one small part, is the state of charge estimation, because the battery management system needs to know what is the charge at the moment. And as we said, this cannot be directly measured from the battery, and we use an AI model to estimate the state of charge. So you can compare that to an extended Kalman filter. You can see, you can also compare how does the Kalman filter behave, how does the AI model behave in our case. And in the end, you want to choose one or the other. Maybe that one is too slow or not accurate enough. So our AI model has as input the voltage, current, and temperature measurements, and the output would be the current battery state of charge. And why would you want to use AI over Kalman filtering? Is because you don't need an internal battery model. So for the Kalman filter, you need to have very detailed knowledge about your battery. And you can train directly on measured data, and by this capture maybe very complex data relationships which are hard to model. So as I said, voltage, current, and temperature measurements are input to the AI model. State of charge, this number between 0 and 1, is the output of the AI model. And here again, you can see the 4 steps that I talked about before. So data preparation, AI modeling, simulation and test, and deployment. Let's look at the data preparation step. So here we use some knowledge about the data or about the domain. So we know that the state of charge not only depends on the current measurement, like measurement at the moment of the voltage, current, and temperature, but also on the history of voltage, current, and temperature. So we added another feature as input, which is moving average of the voltage and moving average of the current. Because we know as domain experts that this might have an impact on the state of charge. So we want to help the AI model to be able to predict the state of charge. So in MATLAB, that's how it would look like. So you have the table, you have different measurements over time. So the time is increasing in the vertical direction. And the response is the state of charge. And now we need label data. And for the label data, this can be efficiently in the lab. So this is an example where this has been done, and you can actually find the data online. So this example, what we're using. But in your case, you might have to use other, like maybe use a physical sensor to do the labeling. Yeah. So here you can see the response. This is then the state of charge, the number that we added in this table. And this is the basis for us to train our AI models. Let's have 3 different options. You could use the machine learning framework to train an AI model. Or you could also interoperate, and I talked about this earlier, with other languages. Like, let's say you might have an AI expert that's already using in Python to do that. So this person can do it for you, and you can incorporate this trained AI model into your Simulink system. Third one is train in MATLAB's deep learning framework. So this is about deep neural networks, which is a special case of machine learning. So when you use the machine learning framework, these are like easier models that you can use. And deep learning, as I said, deep neural networks are models with a lot of parameters. And that comes with a little bit more complexity. So you need to know how to deal with big data. And also for the deployment then of this model, it's harder than deploying a smaller model. That's why we separated these 3 cases. Let's have a look at how this looks like in MATLAB for the machine learning framework. So here you can see the regression learner. And now let's add data into this app. So the regression learner is an app where you can train neural networks for regression. So here we use as predictors voltage, current, and temperature, and these averages that we saw. And then there's something you need to do about how to separate training and testing data. And now this app is really nice. So you can choose from models that you want to train. And so here you can see in the end, you can also like rank your features and say which features were most important. So maybe you had some features that you added that you can remove again because they were not important. So you can see there are also different algorithms that are available for feature ranking. Now, here you can see the different models that you can choose from. And I can also use parallel computing to train several models in parallel. Here you can see how different models were trained, a tree or an SVM, or an exponential one. And here you can see even an ensemble model that was trained. And some also small neural network that was trained. Then you can see which ones are the test data that I want to use to test how well did the algorithm perform on my data. And now you can even compare the models, like with the summary, like which were the results for the regression. And you can say, okay, this is now the best model because it had the lowest RMSE. And I would want to export that. And I can export the model as a MAT file and use it then later in Simulink. So that was a video of how you could use this app to train a machine learning model. And these models don't have many parameters, so they're very small and usually also fast and to apply. And of course, here we are in the AI modeling step, right? Now for the interoperation, it's also possible to import networks that were trained in another framework, like for instance in Keras or TensorFlow, PyTorch, and you can import them into MATLAB and then use them as if you had trained them in MATLAB. Let's see how this looks like in practice. So here you can see it's just about importing a TensorFlow network that was saved from a previous training in TensorFlow. Now it's importing, it's analyzing it. Here you can see this is a user interface for you to get to learn about the network, how many trainable parameters there are, and so on. And now you can apply it on test data and see how it behaves. So you predict battery state of charge, and then you compare the output with the observed data, so with the labeled data that you had before. And you can see the correspondence is quite good again. So that was the example on how you can incorporate trained models from TensorFlow or PyTorch. It's really just one line of code. It's import network, and then you get it. You could also now use the MATLAB's deep learning framework. So before we saw the machine learning and statistics framework with the smaller models. And if you see, oh, I need a bigger model, you can try deep learning as well and design your deep learning model. So again, a video. This is a deep network designer, where you can drag and drop the layers that you want to incorporate and then connect. And then each of these layers has different parameters that you need to set, like what is the input size, how big, how many trainables they want to have for each layer, what is the output size. So this needs some practice to be able to know what could be a good neural network. So here, it's not really deep. We have 211 learnables, but this is just an example. Usually you have more, maybe 20K or 100K learnable parameters. But even here, like when we're using the deep learning framework, and it works also for small models, of course. Then I need to say which ones are my training data, which ones are my testing data. And then you can see, okay, what are the training options? And there, that needs a little bit of practice as well. Which solver I want to use, what are some parameters like the learning rate or validation frequency, the number of epochs I want to train, and some other hyperparameters. This needs some practice, but we also have apps to help you with the choice of these hyperparameters. Then it's click of a button, train it, normalizing the input data. And here you can see the training progress. So this is for deep learning, what you usually do, you train several times, and every epoch, that means I have seen all the training data once, and then you do it several times. So here you can see 5 epochs. And once you're happy, you can export the trained network and the results. So that was a really short overview of what you can do with deep learning. So, but I said, okay, you need to know how to set these hyperparameters and need some practice. We also have an app where you can train several models at the same time or like in parallel, and then with different settings for the hyperparameters. And then it would you would use the model that yeah, gave you the best results. There's also a way of optimizing the hyperparameters automatically. So you don't need to say which ones you want to test, but you can say, I want to start with these hyperparameters. Now find me the best ones that give me the best results. If you have, like now we saw this example with 200 learnables, that's not, usually you have more. You might want to connect to also GPU, because at some point you cannot train this on a CPU anymore. So you could connect to powerful GPUs so that the training will be faster. You could also connect to hosted machines like from AWS or Azure that you could use then these powerful machines to do your training. So the machine doesn't need to be in your office. So that was the example with the deep learning framework. This is another example with the deep learning framework, now this time with an LSTM, so long short-term memory network, which is a special case of deep learning or deep neural network, which can also deal with the history of the data. But the approach is the same. Again, you use the deep network designer. But I'm going to go quick here, so you don't need to see the video. The only difference is the LSTM has more trainable parameters than this small network we saw before. And it takes a little bit more time to train the network because it's a special kind of network. Because it also takes the history of the data into account.